Well, welcome back. And we're here to discuss the properties of rectangles. Now, here's the best news. The best news is that most of the stuff you need to know about rectangles, you already know, because a rectangle is a very specific type of parallelogram. So all rectangles have the same properties of parallelograms. Opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and the diagonals bisect each other. Now we're going to add two other features. The first of these additional characteristics is that all four angles are right angles, right? They all equal 90 degrees. Now that's a no-brainer. You should sort of almost intuitively know that about a rectangle, right? A rectangle has four right angles. Okay, and number two, this is the one that's not so intuitive but should make perfect sense. And that is that the diagonals are congruent. So if we take a look at the rectangle that I've drawn below, and we draw on one diagonal, keep in mind that this is a right angle and that this is a right angle. So I have triangle number one and triangle number two. These are both right triangles. Now let's keep in mind that a squared plus b squared equals c squared, right? The Pythagorean theorem applies for all right triangles. Now because opposite sides are congruent, because a rectangle has all the characteristics of a parallelogram, if I call this side length A, this is also A. If I call this B, this is also B. And the hypotenuse we always label as C. And since that's a shared side, these are congruent triangles by side, side, side. So this diagonal is the same exact length for both sides. Well, no kidding, it's the shared side. But now if we put in another diagonal coming down this way, well, we have a right triangle here and a right triangle here. So if we erased the other two pieces, or I should say erase the portions of the other diagonal, we have essentially triangle 3 and 4. And of course, this side length is still C. And it's the same length C as before because I haven't changed the lengths of A or B. So the diagonals are congruent, and that's provable via the Pythagorean theorem. So four right angles, no big deal. Diagonals are congruent. It's only the really new piece of information. So rectangles should be a cinch. Let's move on. First and foremost, before we go answering these questions, you know what I'm going to say? Fill out the entire diagram. If this is 27, then this is 27. If this portion of the diagonal is 15, then this one is 15. And remember that diagonals bisect each other, so this is the same as this, and also that diagonals in a rectangle are congruent, so all four pieces are all 15 and 15. Okay, so how do we get this side length over here? Well, we have to think like a right triangle now. So we have this diagonal that is going to be our long piece here, that's 30, and we have 27 here, and then we're not sure, so let's call this x. So x squared plus 27 squared equals 30 squared. Take a moment, press pause, and solve for x. So after squaring 27 and subtracting that from 30 squared, which is 900 minus 729, which is 171, take the square root of both sides, and the square root of x squared is x, and the square root of 171 is 13.1, so we get 13.1 for this side and 13.1 for that side. So we have just about everything. Let's take a look now. What do we got? AC is 15 plus 15, that's 30. B to D is the other diagonal, so that's the same length, so we get a 2-4 special. B to E is 15. A to B is 27. And BC is 13.1. That was the one we worked the hardest for. And that's about it. Again, there's no degrees marks here. These are all segment lengths. So you have enough to complete number 1 now on your own. Okay? Complete number 1, then move on with the notes. Press pause now. Now in this picture, it looks like they're looking for a lot of angle information, and I'm looking at the diagram. They only give me one angle right here, but I know that this is vertical, so that's going to be 64 degrees. And then I know that this angle right here is going to be a linear pair, right? I got a linear pair right here, so 180 minus 64 will give me that measurement, and that should be 116 degrees. Notice I put it in both spots because it's vertical. And keep in mind that up here we have a 90-degree angle, and right here I have a 90-degree angle. And also keep in mind that these diagonals got bisected, right? So what do we have up here? I'm just going to highlight this blue triangle. That blue triangle is isosceles because it has congruent legs. And if it has congruent legs, then the angles opposite to them are also congruent. So 180 minus 64 is 116. Now 116 is angle W and angle X, but they're identical. So when I divide that by 2, I'm going to get 58 degrees. So let's just clean this up a little bit. So these base angles are going to be congruent. And then we have an identical triangle down here. So this is also going to be 58 and 58. And also this 58 and this 58 are alternate interior angles, so they're the same. And this 58 and this 58 are alternate interior angles, and they're the same. Now keep in mind, again, that all four angles are 90 degrees. So 90 minus 58 is going to give us 32 degrees. And that's going to be these angles out here. So all of those are 32, 32, and 32. Now we could check this big triangle over here by adding up 1, 1, 6, 32, and 32. 2 and 2 is 4, and 6 is 10. Carry the 1. We got 3, 6, 7, 8, 180. Check. That's good, and that's good. So we have all the angles. So now let's go through and see how we do naming them. Let's see. Angle XWY. XWY is going to be this angle right here. That's going to be 58 degrees. Oops. And YXZ is going to be right here. That's going to be 32 degrees. And WVZ is going to go from W towards V to Z, that big angle right there, 116. Sorry about the jumpiness on the screen. I guess my hand keeps hitting the iPad here. XWZ is going to go from X towards W down to Z, so that's our big one. So that's 90 degrees. We could have answered that right out of the chute without doing any math, right? Just because it's a rectangle. And then our last one is going to be XZY. So starting up at X, going towards Z, towards Y, right there, and it's going to be 58 degrees. So again, really easy to do the math on this one. Just got to take your time and remember that you got two isosceles triangles, right? You got isosceles triangles 1 and 2 right here, and then you got isosceles triangles 3 and 4 right here. So these guys are identical and these guys are identical. And all we had given to us was that one angle. We used vertical angles, linear pairs, and the fact that this was 90 up here to help us out, and isosceles triangles to go from that one given angle to get these two. So a lot of stuff. And as you can see, the knowledge that I learned at the beginning of the year stays with me for the whole year, and I apply it constantly. Let's move on. Actually, before that, you complete, you guessed it, number 3 first. Press pause and complete number 3. Okay, on this problem, we got a little bit of mix and match. We got some angle questions and we got some side questions. So we're going to handle the angle questions first. No particular reason, just feel like doing the angles first. So we got given information here. Angle DAE is 52 degrees. And so I'm going to go find that angle. And I'm going to fill that in. Angle DAE is right here. That's 52 degrees. Now remember, this is an isosceles triangle, and these are the congruent angles. So I'm going to come over here, and I'm going to say 52 twice is 104. And when I subtract 104 from 180, I'm going to get 76 degrees. And that's going to be my vertex angle up here. Now, I have a vertical angle right there, and of course, this is an identical isosceles triangle, so this is also 52 degrees. Now I'm going to use my linear pair combination over here, and I'm going to take 76, and I'm going to subtract that from 180 to get 104. So this is going to be 104 degrees, and up here is also going to be 104 degrees. Now, these two angles are congruent, so I come over here and I say 180 minus 104, which brings me right back to 76. I divide that by 2, and I'm going to get 38 degrees. So this is 38, 38, 38, and 38. Now I just want to check, do these two add up to be 90? Does 52 plus 38 add up to be 90? Yep, so that's pretty good. I also know that the 104, 38, and 38 add up to be 180, and I know that the 76 and 52 add up to be 180, so we're looking pretty good. So now we're just going to answer the questions here. The measure of angle ADC. So ADC is this big one. Well, it's 90 degrees. That was a no-brainer. We could have answered that right out of the chute. Angle ABD. Angle ABD is right here. That's going to be 38 degrees. Okay, no big deal there. Angle BCA is going to be right here. That's going to be 52 degrees. And angle DEC is going to be this angle up at the center there. That's going to be 104 degrees. And so we got 90, 38, 52, and 104. So now what I'm going to do is I'm going to erase the board here and start over with the side lengths. So let's move on to what we've been given. First, they give me that DB is 42. So this whole diagonal is 42. Now we know that diagonals get bisected, so half of 42, right, is 21. So this is 21 and this is 21. And because the diagonals bisect each other and they're also congruent, then this is 21 and this is 21. Okay. And then we have that AD is 26. So this is 26 and opposite sides are congruent. This is 26. Now what about AB? We're going to have to, again, take the concept of this right triangle right here. Well, the whole length of the diagonal was 42. This is 26. This is an unknown. So x squared plus 26 squared equals 42 squared. And remember that the reason I'm putting 42 on the C side is it's the hypotenuse. Just because I have two numbers known doesn't mean I always have the hypotenuse on a leg. I just label the sides correctly. I draw a right triangle and I use the Pythagorean theorem appropriately. So be careful that the unknown is in the right spot. And now we'll just take a moment and perform the arithmetic. Press pause and try it out yourself. Okay, so I come up with x, or that unknown side is approximately 33 units. So don't just blindly copy the notes. Make sure that you're pressing pause and you're thinking about what's going on. Feel free to stop and come ask me questions. If you're not really thinking this through on your own, then you're having a passive education, and that's not why we're doing this. We're looking to build critical thinkers, right? The whole purpose of mathematics, to get you to think on your own, to problem solve. Why am I doing this? Learning how to problem solve on a daily basis. Life gets difficult, and there are no answer keys. Math will help you through the difficult times. I know that sounds crazy. Anyway, let's get back to business. We got all our sides labeled, so let's just start answering questions. Let's see, they want AC. Well, AC is that whole length there. That's going to be 42. EB is going to be from E to B. That's going to be 21. No problem there. BC is the side over here. That's going to be 26. And A to B from our Pythagorean theorem work, 33. Again, that was the one that we had to work for. Notice no degree signs there because those are segments, and that is a big deal, and I will take off on assessments if you mislabel the units. Units give meaning to the numbers. Please make sure you give appropriate meaning. Now what? Aha, of course, on to the algebra. This is super easy. Opposite sides are congruent. When congruent, set the terms equal to each other. Now, I noticed that we're still having a lot of trouble with this basic algebra here. A lot of people say that the next row is 10x. No, it is not. Okay? So be careful not to make that mistake. Do not confuse combining like terms with inverse operations, right? When you cross that line, you have to use inverse operations. And then the goal is to get everybody to one side. Constants to one side, numbers to the other side. And then isolate your variable. X equals 11. Done. It might be worth saying that 3 times 11 plus 5 is 33 plus 5, which is 38. Okay, so that's this side. And then 7 times 11 minus 39 better be 38. 77 minus 39. Well, let's see here. That's 8, 38. Check. Sounds good. I think that x is 11 almost answers our question. Find the length of EF. EF is 38. So I guess the final answer to our question is 38. I almost messed that one up. Now, how much different is number 7? Well, first, just find out where RT is. RT is this diagonal. And then US is what? The other diagonal. And what do you know? Diagonals are congruent. So, no brainer, 5x minus 14 equals 2x plus 10. And then find the length of VT. What's VT? Half of the diagonal. So first, let's go figure out what x is. Take a moment, you solve it. I'm going to want to see your notes and I'm going to want to see the algebra completed. I'm just going to give you the final answer for x so that you have something to verify. You press pause, solve x now. So you should get at the end of the day that x equals 8, right? Don't forget to subtract 2x or 5x from both sides. Watch your signs. And you should get that x is 8. Well, now what? Let's substitute 8 back in for one of the x's. So that's going to be 40 minus 14, which is going to be 26. Now 26 is the length of both diagonals. So half the length is going to be 13, 13, 13, and 13. So at the end of the day, how long is VT? VT equals 13. And that's what your final answer should look like. But you should have all of the algebra here for actual credit. Okay, again, side lengths, nothing to do with angles. I don't see any angle information here. VW is 9x minus 11. Okay, so that's 9x minus 11. And SU is 16x minus 12. SU is, right, this whole thing is 16x minus 12. Now, what do I know? I know that this is twice the length of this. So 9x minus 11 twice is worth the same as 16x minus 12. Again, the whole diagonal is 2 of these. This whole diagonal and this whole diagonal are the same. So to get 16x minus 12 to be worth the same as the other algebra expression, I have to double it, which is 18x minus 22 equals 16x minus 12. You work the algebra out on your own. You should get an x equals 5. Again, I'm going to want to see all of the algebra to actually give you credit. And then find the length of WT. And WT is going to be worth half a diagonal. So I guess I would probably pump the answer for x into that. Otherwise, you have to put into this and turn around and divide by 2. That doesn't make any sense. That's working too hard. Move on. This answer has to do with angle stuff. So again, I got to think about everything I know. Consecutive angles, alternate interior angles, vertical angles, linear pairs, all kinds of stuff. And now what do I see? I see that this angle right here, I know is the same as this one. Okay? And then I know that this angle right here is the same as this one because they're alternate interior. So isn't 5x minus 8 also right there? 5x minus 8. Well, of course. Okay? That one's right there. And what do I know? This whole thing's 90 degrees. Ah, well, that's helpful. X plus 20 plus 5x minus 8 is equal to 90 degrees. All right. Well, now, again, know the difference of when you're using inverse operations versus combining like terms. This, my friends, is a combining like terms opportunity. 6x, right? I don't subtract x from 5x. No changing of signs. I'm just pushing things together. And 20 minus 8 is a positive 12 equals 90. Now I'm going to use inverse operations because I'm crossing over the line. 6x equals 78 divided by 6 divided by 6. And I'm going to get x is equal to 13. Now, does x equals 13 solve the world's problems for this one? No, they want the measure of angle XZW. All right, well, let's go find it. XZW is right here, this angle. And we said that that was worth 5x minus 8. So I guess I'm going to take the 5 times my value of 13 and subtract 8. Okay, well, let's see. 5 times 13 is 65. Minus 8 is 57 degrees. So I guess the final answer for this is the measure of angle XZW is 57 degrees. How about 11? Is this side business, segment business, or angle business? Looks like angle business to me. The measure of angle JHI. So we're looking for JHI, this angle up here. Now what's the same as that? This one right here. Now I know that this is 90 degrees, so I'm going to take these two angles. I'm going to do what? Same thing I just did a few seconds ago. I'm going to add them up, set them equal to 90 degrees, right? Remember, that was the definition of complementary, right? The measure of angle A plus the measure of angle B equals 90. That's these two right here. These are certainly complementary angles. Once I solve for x, I'm going to take x and I'm going to substitute it into this value because this and this angle are the congruent angles because they are alternate interior. So you should be able to complete number 11 on your own. And the last example that we have in this video is to solve just for x. Okay, well, first keep in mind that we got ourselves a isosceles triangle right here. And I know that I can solve this angle right here because 134 and let's just call this y are supplementary. So I take 180 and I subtract 134. And I get myself 46 degrees. So that's 46 and that's 46. Now keep in mind, these two angles are identical. So 180 minus 46 would give me the measure of both of those. So I say 180 minus 46 is going to be 134. But that's both of them. I divide that by 2 and I get 67 degrees. So this is 67 degrees and this is 67 degrees. Well, isn't this an opportunity? 5x plus 7 is the measure of this angle in algebraic terms. 67 is the measure of that angle straight up. So I guess 5x plus 7 is worth 67 degrees. Well, then I guess 5x is equal to 60 and x is equal to 12. And they said solve for x, so I guess we're all done skis with this problem. Now you should finish up all the other problems on this page and you should have your notes squared away for pages 1 and 2. And the rest will be for another time. Hopefully this was helpful. Check this in with me when you're done.